towards resilient society. The 21st century is experiencing extreme weather events, and India has been ranked number 3 after China and the US in recording the highest number of natural disasters. And here today we are talking about so-called man-made disasters. Uh, so between 2000 to 2019, there have been 7,348 major recorded disaster events, almost double as that of the previous decade. And even when you look at the global economic losses, which amounted to 2.97 trillion US dollars, compared to the previous disasters losses, which were just $1.63 trillion. So when we talk of disaster risk reduction, it's a systematic approach to identify, assess, and reduce the risks of disasters and to minimize vulnerabilities and disaster risks throughout society, to avoid, which is prevention, to limit, which is mitigation and preparedness, the adverse impacts of hazards within the broad context of sustainable development. Now, as we can see, disasters and development have a very close linkages, and especially when we talk of industrialization and industries. And disasters and development have to be uh, very sustainable, and especially we have to be mindful of the kind of development we want, which should be sustainable and also reduce the risks of disasters rather than aggravating. We need to apply DRR practices from the lowest level of an individual to the community, the state and nation, and at global level. Power industry is so important when you look at from gender perspective. I would like to give a very brief 2 minute discussion on that. This reminds me of a book which I reviewed long back on Seeds of Disaster, Roots of Response, a US publication where the private sector engages with disasters. And because the losses are so immense and it affects private sector also, and especially the industry. So all the industrialists had come together to write about the losses and how they can engage to bring in the DRR. Coming from gender lens, the power industry is yet to break the glass ceiling. While gender disparity is present in every industry, the power sector is predominantly male dominated, with a gender gap still permeating power company boardrooms. And I am sure all of you agree on that. Opportunities for women in renewable energies are immense. And as we can see, power sector has huge benefits for women in general. When you look at the renewable energies, which all the women in every household are using it, be it in India or in the neighboring countries like Bangladesh. And we have seen how power actually helps women to spare more time in their other occupations compared to women who are into traditional use of energy. So, in order to improve the quality of life for women and especially the families and the community, the energy sector has immense role to play. With these very brief words, I would like to welcome Shri A. Pandey, Regional Executive Director West 1 of NTPC, nation's largest power generating company. We are indeed very glad to have him today for this webinar. He will share disaster risk governance issues from NTPC power sector points of view. Shri A.K. Pandey is an accomplished power professional with over 36 years of comprehensive experience in the management of large-size thermal as well as renewable energy projects in the area of project construction, project management, and O&M. Presently, he is heading the Western One of NTPC Limited, which encompasses 2 coal-fired, 3 gas-fired, 1 solar, and 1 wind power stations of NTPC. He is also heading a team for NTPC's first upcoming ultra mega solar power project in Bhuj, Gujarat. His current responsibilities includes overseeing the safe and reliable commercial operations of these stations and regulation of total contracts and finance of the region. His experience at senior level project management ranges not less than 16 years in time in 5 geographical sites and with several technical segments and many others in renewables, and that all at increasing key positions. Recently, as head of Gadarwara project. He was widely recognized for his achievements in terms of flawless commissioning, initial trial operation, and stabilization of 2 into 100 megawatt units, which is the first unit in NTPC of 800 megawatt size and Siemens and GE technology in collaboration with BHEL. I'm glad to have Anil Pandey and I'm sure the organizers, uh, on behalf of the organizers and all the audiences who have joined today, we welcome you, sir, for today's talk. If you can share your thoughts for half an hour to 40 minutes, and then we'll have question and answer session to address any queries with the participants. Over to you, sir.
Thank you, Professor Sunita, madam. Respected Rakesh Dubey Sahab, who is really the pioneer in disaster management in this country. Other distinguished members who are connected on this platform, my dear friends, I'm extremely feeling honored to be introduced by Madam Sunita, who is a professor in JNU. But I don't know whether I would have got a chance to go to JNU, but then interacting with you is a real pleasure and honor. I would like to share my views on this important topic like disaster risk reduction, which is really affecting the humankind as a whole. Like Madam was telling that losses due to disasters are running into trillions. We as power plant professionals who are engaged in meeting the energy need of the country, we in fact act as an engine of growth of this economy. Because if there is no power, there is no development. If there is no development, there is no economy. So we have been trying our best in these trying times when the pandemic is on and really working is very difficult. In these times also, we kept our operations on. And in fact, in the last month, we in fact excelled from what we did in the earlier year in the same month. Just to give further impetus to the economy and to contribute our bit in the overall development of the country. Now, I have prepared certain documents which I'll be sharing with you all. I hope I am audible and this slide is visible. If someone can respond, it will be better for me.
Yes, sir.
Yes, sir, you're audible.
Yes, it's visible.
So primarily we are talking on the disaster risk reduction. What are the challenges and what are the way forward? What the topics I would like to cover is how the Indian power sector is, how NTPC is placed in the overall Indian power sector, what are the hazards in our power plant operation and maintenance, how these disaster risks in power plant are identified and mitigated, then what are the key learnings and the question and answer session, which of course is going to be mutually beneficial for both of us. So this in a nutshell, I would like to cover. So first coming to Indian power sector. Today, the country is having a generating capacity of about 3,72,000 megawatts. It has got a whole mix of thermal, which is primarily coal-based. We have got gas-based power stations, nuclear power stations, hydro power stations, and renewable. Now, as a percentage terms, today also 55% of the total generating capacity comes from thermal. 24% is coming from renewable, which of course is catching up very, very fast. In fact, the maximum capacity addition is now coming from the renewable sector. Hydro, we are having 12% capacity. Nuclear is just 2%. And gas, we have got 7%. And diesel, of course, is all totally shrinking. It may go down. Presently, it is at 510 megawatts. Now, as it is just for your information, how in the pandemic period, the demand of power, almost went down to minimal. You see, if you can see this graph that is presented before you, in the month of February, we were having a demand roughly about 165 gigawatts, 165,000 gigawatts, which in the first week of April or in the end of March, it went to as low as 110,000 megawatts. But after the economy was opened up, the lockdown period was unlocking started. We started catching up with the power requirement, and we again, you see, the yellow lines are showing the power requirement in the last year, and the blue lines are showing the power requirement this year. So you can see that now we have almost come to a phase, and in some days we are even crossing the consumption in the earlier year. So almost we have come to normal as far as the power generation and power consumption is concerned. And NTPC is again, trying to excel in meeting the requirement of total power for the country. So as a company, we are having a vision, and the vision is to be the world's leading power company, energizing India's growth. And the mission is to provide reliable power and related solutions. It is not only providing power only, but also related solutions in terms of, providing electrical vehicles, providing distribution support, going for hydrogen technologies in an economical, efficient, and environment-friendly manner, driven by innovation and agility. And as a company, we in fact have got the strongest core values, which we call it as I commit. I stands for integrity, C stands for customer focus, O stands for organizational pride, M stands for management excellence, and C stands for commitment to excellence. So we
Hello. I think we lost Pandeyji voice. There's some network issue is running from his end.
We'll wait. Can you call up, please, and check?
Yeah, we are trying, ma'am. Till then, Dr. Rakesh, sir, and you can have a full discussion about the thing. If anybody has question, they can start. We can discuss on that. We're just checking the issue with the event.
Sure.
I think I had lost the connection. I don't know where from it got disconnected.
Yes, sir. We are just waiting for you. Yeah, please. You are audible, sir, now.
Now I'm audible, but where I have to restart, I don't know.
You have to share your screen, sir, once again.
Okay. That I will do. But where actually we got disconnected?
Yeah, on the fourth slide or fifth slide. You had just come to fifth slide.
Core values?
Yes, sir.
Okay. Sorry, actually. We are in the remote corner of the country, so I'm presently in Madhya Pradesh at Gadarwara, Narsinghpur. So, okay. We were only trying to share with you that with 17% of the total installed capacity of the country, NTPC today is meeting the requirement of more than 21% of the total load in the country. So that shows our operational efficiency, how we are actually operating. In the last 1 year, we generated about 290 billion units of power, against the rest of India total generation capacity of 1095 megawatts. Sorry, billion units. Hello. Hello.
Yes, sir, you're audible. Please continue.
Okay. So you can see the future scenario for NTPC. Just to take you a bit, we just tried to show how we were in 2017, where we are going to be in 2022, how we are going to be placed in 2017, because we have got a plan up to 2032 to be a 132 gigawatt company from our present strength of 62 gigawatts. So you can see that maximum capacity addition that, see, when 2017, we were just 800 megawatt in terms of solar, but we are now planning to be at 30,000 megawatts in solar by 2032.
एमपी में जो आप रेट दे रहे हो, मुझे अगर वो रेट देते हो तो 3 लोकेशन
Please continue.
Disasters,
Yeah.
which we are here to discuss. Now, disasters are a product of the hazards that exist, whether these are man-made or they are natural. Now, and if these hazards are not managed properly and are not prevented, they can lead to disasters. Now, and hazard and disasters, they have got a relationship. Hazards, if your preparedness is not proper, if your response is not okay, and the severity of the hazard, if it is high, it can lead to disasters of larger consequences. This may cause loss of life, damage to property, damage to environment. Hazards basically, again, these are the punch of nature or human act. It can be human error also. And then the vulnerability, if we are not very much prepared, the vulnerability is very, very high. And any small hazard can lead to higher damages. Then comes the, what are the key elements of disaster management? As a company, how we prepare ourselves for this disaster management. Now, there are 4 distinct phases of disaster management. One is what we do before disaster, what we do at the time of disaster, what we do immediately after this disaster, and what we do in the long term. So before the, actually, whole management or whole efficiency of any system depends what we do before disaster, because any prevention, the cost of prevention is just 4% of the overall cost of, if we try to respond to a disaster, the cost is going to be multiple times. I mean, one of the empirical calculations is that the money spent on prevention is just 4%, and money is spent on responding to this disaster after it has happened is roughly about 96%. So what we do before disaster is communication and sensitization. Supposing we are in a zone, we are supposing establishing a power plant which may have a hazard of, say, chlorine storage, oil storage, gas storage, hydrogen gas storage, which may have on-site or off-site impacts. So we must communicate, we must sensitize to the, not only the working people in the plant, but also to the area that is going to be impacted regarding the possible impact that it can have. Then identification of vulnerable areas. What are the areas which are very vulnerable, whether we can keep them cordoned or we can take some measures to prevent its spread. Then setting up control. Supposing a hazard happens, so we must have a system to, there must be certain sensors, certain transmitters, which will sense the danger in the initial stage, and they will issue warning sirens or warning alarms. And then there has to be a monitoring mechanism where every data is captured and we are able to foretell that yes, such incident may happen, and we can better prepare ourselves. Capacity building, testing, and evaluation of emergency plan. These are things which we have done and we rather should do before any kind of development project is taken up, or which may have the hazardous situations where disaster can happen. Can happen. Plant operation, whether we should stop it immediately or we should keep it running, what is going to be in the best interest of the vicinity or in the best interest of the company. Then evacuation, assembly points where supposing some disaster happens, where the people are going should assemble, and then controlling and monitoring who will monitor, who will report to whom. And then immediately after disaster, physical communication, rescue and medical relief immediately to the people, rescue of the assets, your plant and machineries, restoration of basic needs, and establishing an alternate communication network, because many times once a disaster takes place, the entire communication network goes off. And in the long run, restoration of plant and facilities, which is the last and final stage, including township, is extending help to surrounding areas, and recognition of the good work. Now, though there are many hazards, but we would like to discuss one such hazard which is existing in the plants, and that is the hazard due to leakage of chlorine gas. Now, chlorine in the plant we use almost on a daily basis, because power plants are the biggest user of water. And any water, if it is used in the plant or it is used for drinking purposes, it has to be treated with chlorine to take out the bacteria, to remove algae, and we store chlorine which may leak because of the malfunction of the walls, because of improper storage, because there may be leakage in the line. And if we are not able to contain it in time, it can spread in wider areas. And once it spreads, it can cause a lot of anxiety in the people, coughing, burning sensation in throat, eyes. It may damage the respiratory system. It may even lead to death. So this is a real emergency, real disaster if there is a chlorine gas leakage in the plant. Now, what is the impact? Because all these things are assessed beforehand. And the impact, like the most vulnerable area, the orange zone that you are now finding, where the concentration of chlorine can be as high as 35 ppm, and which is really in the lethal concentration zone. This area we keep cordoned off so that nobody is allowed to enter, except those who are really trained to handle chlorine and to take necessary action once there is a leakage. Then there is a blue area, this pink area, which is roughly, say, about 2 kilometers spread. This again is less impacted, but it may have a dispersion of about 10 ppm. And then the blue ones, which is spreading up to 4 kilometers, this may have a dispersion of about 3 ppm. And beyond that, of course, is a growing green zone. So we need not be very much concerned. But up to this point, up to the blue zone, we have to be concerned. We have to sensitize these people. We have to keep these people prepared. And we have to our own response mechanism. Now, how do we handle it? First of all, we have got very, very high sensitivity chlorine gas detectors. Wherever the chlorine is kept under store, the detectors are installed, and even a small amount of chlorine leaking will immediately, the detectors will act. And what detectors will do is, there will be a siren alarm, and it will give an auto command to the chlorine gas absorption system that will act, and it will absorb all the chlorine that is coming out from the toners, from where the leak is taking place. The water curtains will be kept on so that at the entry and exit gates of the plant. And then there are kits for plugging the leak, there are there are breathing apparatus sets available, self-contained breathing apparatus sets which are available with the operators, with the CISF, who really go and do the plugging of the leak portion. This manpower is totally trained in operation of the chlorination system, including the CISF. And as a last measure, now when we found that even this is not going to be very foolproof kind of thing, what decision we have taken as a company is that in all our plants, we are now replacing this chlorine gas with chlorine dioxide system, which is absolutely hazard free and will not cause any kind of distress to either our people or to the community as a large. So this was a small example of how chlorine can cause a problem and how we have tried to mitigate it. So this basically is the process that we adopt in any kind of development projects that we take. First of all, we identify the hazards. Hazard identification and risk assessment is the first thing. Once the identification of hazard has been done, we go for identifying the engineering control system. And based on that, the projects are executed. We execute that. And then that is evaluated whether it is really meeting the requirement or not. And once it is established that it is meeting all the requirements of the hazard, then only the process is rolled out. Otherwise, we again go and identify, and this kind of iteration keeps on taking place. Now, these are the engineering preparedness. Once we take everything under control during the process design itself, the second layer of separation is we keep the area barricaded by separation distance. Then process safety devices are there, controls are there, alarms are there, and then of course last is the administrative processes and controls. This is a model of the disaster management system that we keep in all our plants. Because as I was telling that the disaster can be because of the chemicals, it can be because of fire, it can be because of explosion, it can be because of colossal structure, it can be because of natural calamities like cyclone, floods, earthquake, or it can be man-made disasters. So there is a shift charge engineer in the plant, which is 24 hours available. There is a control room where shift charge engineer is there, and there is a control room, a fire control room, where any kind of incident taking place is first he is getting the alarm in the control room. He further makes an assessment whether it is something we can control. It's okay. If he cannot control, he declares an emergency. Once an emergency is declared, then all the support functions immediately get activated. The emergency control room, the emergency alarm, the assembly point, the medical and firefighting team, and all mitigation measures. Every organ gets immediately activated, and the action is all till such time the all clear signal after the situation of emergency is not declared by the incident controller. Now, what are the challenges in disaster management? Because disaster management is basically a comprehensive strategy based on a set of activities to reduce the risk. And how do we reduce the risk is by reduction of vulnerability of the elements of risk. Element of risk, supposing chlorine is the risk, we reduce it so that the vulnerability of this risk is reduced. But there can still be certain things which we call it as an act of God. But even for the act of God also, if we make our preparedness foolproof, we can reduce the vulnerability. Ensuring that adequate measures are implemented before disaster strikes. Responding as efficiently and effectively as possible to disaster. Assuring a sustainable development of the affected region. And we are also trying to meet, not only trying, but we are ensuring to meet all the environmental norms on the emissions of nitrogen oxide, sulfur dioxides, to reduce the impact of greenhouse gases, which are having long-term impact on our environment. Now, how we do it? We prepare a disaster management plan in all our plants, get it approved by the statutory authorities also, and we ensure its implementation. We also get the risk assessment done through external expert institutions. We have got in all our plants full-fledged CISF, which is a Ministry of Home Affairs body for firefighting and emergency rescue activities. And we carry out periodical mock drills and review the efficacy of the drills. Then on firefighting side, there is regular inspection of fire reduction and protection systems, review and updation of plans from time to time, playing responsible role in disaster mitigation and responsible activities. And we also partner with local administration for risk reduction. So coming to an end, since it is a very, very large and very august forum, on behalf of NTPC side team, we would like to, reaffirm our commitment on this auspicious International Day for Disaster Risk Reduction to do our bit to ensure a risk-free environment, a disaster-free environment for all those stakeholders who are associated with us. Thank you very much. Thanks a lot.
Thank you. Thank you so much, Pandey sir. It was a very interesting talk, giving all the dimensions of industrial preparedness, especially for disaster risk reduction, and looking at the on-site plants and the mock drills, which are done very frequently. And this also reminds me of my own visits to give lectures with series of seminars on conferences organized by FICCI a few years back. And whenever I spoke about disaster preparedness at the industries, especially the hazardous industries, and also looking at the off-site plants, because on-site plants, of course, we are very well equipped. But off-site plants, when I spoke to the managers, they all said that we are very worried about not able to reach out to the community, which are staying close to these industries, because the moment we tell them the hazardous material which is being manufactured there, then they won't allow us to work. And however many of them may be working in the units, still it's very difficult to convince the community around about the material and the preparedness. But I feel that we have seen major disasters. Bhopal, nobody can forget, it's been more than 4 decades. And I had an opportunity to visit the site also a few years back, where I could see that even today, that place is contained. We can see the unit as it is, and it's all closed because we are told that the contamination is still there around the unit, and that's why nobody is allowed to go. Even if you want to make a visit, then you have to take the permission of the DC. So I felt that it's very important that one, we need to see how we can communicate to the community around and make preparedness plans, because even the gas leak which happened recently in Vishakhapatnam after COVID, we could see that had people known about the material which is being used there, some precautionary measures could have been done. The same goes with the Bhopal accident. And even today, the court cases are running. And second point I want to really bring out is the memorials. Like post tsunami, we have seen a lot of memorials abroad. There are so many memorials after any disaster or any war. So we could have built a memorial for Bhopal accident too, and that reminds us of the problems which we face, the challenges which we faced, and the preparedness we can. It will be more like a knowledge base for the younger generation who can visit those sites, and it will also generate some revenue. So this is again an idea I've been sharing with many people. I suppose having Dubeji around and many senior professionals here, this idea can also be discussed. So I would like to really thank you, sir, for such a wonderful talk. And I open this session for question answer session. Those who are interested can raise their hands or even leave questions in the chat box. We can take a few questions before we close the session for today. So there's one question which has come up. Chlorine dioxide doesn't cause any hazard. Isn't it a chlorine dioxide generation system or by blending with any other chemicals? Sir.
Chlorine dioxide definitely is not hazardous. In fact, we produce chlorine dioxide, ClO2, the name that we use it for, by chemical reaction of hydrochloric acid with NaCl. And there the ClO2 is produced, and this is not at all harmful, and the chances of any kinds of gas leakages are not there. So, and it is in fact less costly also. See, the cost of power also is one of the major factors. And if we are using say 100 kg of chlorine gas, we need to, I mean, the ratio of chlorine dioxide requirement is, I think, 1/3. So in 30 kg itself, we will be able to have the kind of impact on water treatment by using chlorine dioxide. So this is basically installation cost is a little more, but O&M cost is less.
Thank you for that clarification, sir. There have been a few compliments for your talk, very informative talk. A question by Colonel Sanjay Srivastavaji. NTPC is a power giant. How much of your CSR contributing to offsite disaster management? And it's an excellent presentation. Along with Sanjay Srivastavaji's question, my own query, because when I realized talking to the FICCI officials and also the managers, I had a plan to do a small research study. And I had been to FICCI and also to NDMA asking for some funds to do small on-site research to understand the perception, the fear, and the preparedness at the off-site plant. But unfortunately, it didn't happen. When I spoke to them, they said we have all the list of the hazardous units across the country. But I think it's a good idea to use the CSR funds for, say, projects like small researches and also preparedness by the community, involvement. Would be very happy to know your response.
Actually, for me, it will be difficult to give sector-wise allocation of CSR funds. We do believe in overall growth of the area wherever our projects are situated, and basically we have got 5 sectors in which we do our CSR activities: education, health, girls empowerment. In fact, GEM, we call it Girl Empowerment Mission, is one of the our flagship projects, where in the remotest corner of the country, like district Sonbhadra in UP, district Singrauli in Madhya Pradesh, where the children, girl literacy rate is very, very low. There we have adopted nearly more than 100 girls, trained them in our township, kept them in the environment in which with all the kind of facilities, and 2 months, which is a month of summer when the holidays are there for the children, we provide them every kind of training, which goes a long way in making them confident and making them understand on our operations also. Like you were telling, people are very hesitant in telling the kind of risk to the community. But as a company, we are very transparent. In fact, in our environment impact assessment, whenever we do a project, these are the things we list out. Yes, these are the processes that are going to be used, and the community at large should be aware that this kind of risk exists. And to mitigate that risk, first thing is to educate them, and the second is to enable them. Like enable means providing the kind of infrastructure, like roads should be there, drains should be there. So these are things we are definitely doing. So health, education, girl empowerment, and infrastructure. And for there is a fifth dimension also which we are using. There are 5 basic categories on which we are doing the CSR, and it is roughly about 300 crores a year as on a company basis.
So that's a good amount and very well spent. I'm sure, I mean, educating and making people aware around the units also will go very well, especially in the DRR, given that they are the most exposed, they are most vulnerable and in the nearby vicinity of the plants. Few more questions, sir. Where chlorine used as gas in power plants? I mean, is chlorine used as gas in power plants? I think there's one question.
No, chlorine, we are storing chlorine as gas, and then we are liquefying it, and we are adding it with water to kill the bacteria, to remove the algae. So chlorine as a gas is stored, but when we are using it, we liquefy it.
Right. Another question, who are the manufacturers of chlorine dioxide in India and what the cost ratio to chlorine? Do you have a separate department for DRR and BRM at NTPC?
I could not get it properly, but chlorine gas is produced by many companies, mostly companies which are engaged in like paper mills, wherever there is a chemical process as a byproduct. If chlorine gas is coming out, they bottle it in cylinders and sell it. So we have got a separate water chemistry department which is supposed to handle these gases for proper preservation, proper upkeep, and proper utilization with safe conditions.
So, another question, how is the fly ash disposed and what are the environmental hazards of it?
Fly ash, traditionally we were making it in the form of slurry and dumping it in the dikes. But now fly ash is one of the most important assets that a thermal power plant today is having, because fly ash today has got multiple uses. It starts from making roads, and then adding directly to cement, because you may be knowing cement, 30% of the 30% of the ash can be directly added to cement to make it PPC, and then we can even use it in fields also for improving the fertility. We are making we are going to use it in, even in place of sand also. There is an experiment. So a lot of pilot projects are on to see that fly ash, which was rather a waste material or unwanted material, is now something for which people are paying and taking. And we, in fact, fly ash is a mission for us. Fly ash, 100% fly ash utilization is a mission for us.
Okay, any environmental hazard because of that?
No, environmental hazard as such, if it is left, see, it has to be handled properly. Supposing we leave the fly ash in open, so it will lead to lot of fugitive dust emission, and that will damage the environment. So wherever we used it for dumping also, we always ensure that after the fly ash is dumped in the pond, above that we create a layer of minimum 500 millimeters of earth to suppress any kind of dust coming out, as dust coming out in the environment. So if it is left without cover, yes, it is an environmental.
So a related question, sir, how about mitigating climate change due to power generation as the main focus?
It is a concern, and that's why the world as a whole is shifting towards RE. But that shift will take time, and till such time we don't have the storage technologies matured. Because the problem with RE, renewable energy, is that it is available only in certain part of the day, and rest of the time you need to have certain kind of battery storage or some other kind of storage. And the storage technologies today are very, very costly. So till such time that technology doesn't mature, we have to rely on thermal power to meet our needs. But definitely, we as a community definitely have to migrate from this thermal business to renewables, slowly but surely.
So there's another question which says that there are much more cheaper and safer processes and methods available. Basic water analysis and treatment can be reduced to greater level at source as well. Research in the area is being done by us, which is Piyush Tripathi's question, and results are good. Last visit to Kawas and Jaina, we saw, but now that process installation of CL alternative are going on. But still, it is possible to be properly connected with you, can assist in developing more economical and safe alternatives.
That's fine, madam. I think we are more than open to any kind of better process that we can adopt. We are a very, very dynamic kind of organization and always would like to move forward. If there is any alternative technology, there are only first parameter, it has to be safe. And second, of course, is cost effective. So on these two parameters with the kind of gentleman number, I'll talk to him and I will see that is.
So I think Piyush can connect to Pandey. There's another question by Professor Joshi. There are also other challenges of waste management and switching to new and renewable energy. What mechanism NTPC is applying for these? What is the efficiency?
No, waste management of renewables.
Yeah, it's not renewable. It's basically challenges of waste management. And because of those challenges, can we switch to new and renewable energy? And if NTPC is looking into these issues. Professor Joshi, if you want to ask the question directly.
Yes, yes.
Yeah, Pandeyji, namaskar. First of all, thank you very much for such a detailed, insightful viewpoint of NTPC. But though one of the participants talked about this ash, and you talked about there are multiple usages of that. But still, when we talk about thermal power plants or NTPC per se, the lot of waste which is coming out, that still remains challenge across Chhattisgarh, Madhya Pradesh. We get to understand this. Then second thing is entire world and country is also looking towards renewable. So if NTPC has any kind of plans towards that, and what kind of mechanism are you using? First, for waste management. Second, for getting converted to a new and renewable energy. Over to you, please.
So, I think, can you hear us, sir? There seems to be some network connection again. I think we lost connection.
सुनीता जी, मेरे ख्याल से सर जब तक कनेक्ट करते हैं, मैं सर की तरफ से एक छोटा सा जवाब दे सकता हूँ एनटीपीसी क्या कर रहा है. एनटीपीसी हैज एक्चुअली इनिशिएटेड रिन्यूएबल एनर्जी टू फुल फोर्स. यहाँ पे वाटर पेट पे भी इन्होंने पहला रिन्यूएबल स्टेशन बनाया है पानी के ऊपर. इन्होंने पैनल्स लगाए हैं. बहुत अच्छा प्रोजेक्ट था और ब्यूटीफुल प्रोजेक्ट है. ये गुजरात में एस्टैब्लिश किया है इन्होंने. बहुत ब्यूटीफुल तरीके से इन्होंने रिन्यूएबल एनर्जी के ऊपर फोकस करना शुरू किया. रिगार्डिंग वेस्ट हैंडलिंग सर आप बता सकते हैं. आ गए हैं, ज्वाइन कर लिया सर ने. सर प्लीज सर, वो मैंने सिर्फ एक चीज ऐड कर दी सर कि एनटीपीसी ने पानी के ऊपर भी रिन्यूएबल एनर्जी के पैनल्स लगाने शुरू कर दिए हैं. सो दैट इज वन एरिया वेयर यू हैव एक्सेल्ड and a benchmark is already created. I just wanted to the question followed was that waste management में हम लोग क्या कर रहे हैं and how thermal and renewable energy waste is being handled. उसका जवाब सर पूछना था.
Please unmute, sir.
Thank you, madam. So first of all, I would say thanks to Joshi sir. Very, very loaded question in terms of waste management. I would categorize it in two parts. For a thermal power station, the biggest waste is ash, which was hitherto called waste, but we are trying to make it an asset. And already in many of our power stations, particularly those who are nearer to the locations where cement plants are there, it's already in great demand. Every year we are trying to improve our ash utilization percentage, and definitely our target is to have zero ash in the dike. All ash we want to be utilized. The other waste in any industry, like we may have lube oil or we may have certain other process waste, we have got a very well documented waste management mechanism where the waste is segregated into recyclable or non-recyclable. If it is a non-recyclable, then if it is an oil product, we are giving it back to IUC. We are having a, for most of the things, we are trying to have buyback arrangement where the product can be taken by the manufacturer himself. He can do something to again put it to use. So 3 R's: reduce, recycle, and reuse. So these are the 3 steps that we always try to take for any kind of waste that we are generating. For me, it is difficult to, at this stage, comment on the waste management of renewable energy, because that is another area which is really challenging, that how we are going to manage the waste of renewables. So that part I am leaving it for today.
So, Professor Shiv Prasad had asked this question on fly ash. Related to that, another person, Santosh, is asking whether if we use boilers in small quantities, can that reduce some kind of pollution?
In fact, as the size of the boiler goes down, the efficiency of the plant goes down. So as we scale up, like today we are having the highest efficiency thermal power plant, which is again belongs to NTPC. It is at Khargon in Madhya Pradesh. It's a supercritical technology plant where the efficiency is as high as 45%. Smaller size plants, boilers, by nature, they operate in an efficiency range of 30 to 35% only. So the moment your efficiency is low, you are firing more coal to get the same amount of energy, definitely the losses are more. So I don't think that is going to be idea that holds good for today. Today the call is that we should be highly efficient, burn less and less coal to get more power.
Right, sir. So there are a couple of more questions. How much time do we have, if organizers can tell us? Because we have crossed 1 hour. So
We have more 10 minutes more. We can just
okay,
wind
we
up.
can go for 10 minutes. I
Please.
think there are 4 or 5 questions quickly if we can answer those. So this
Can I ask?
yes.
Yeah, yeah, I'm Narendra, and I'm also from the organizers section. Well, we work in statutory health checkup. So we usually, go for a health checkup of organizations and employees. So we face this concern, like we certainly have this fitness test of employees. So in power sector, especially when employee get exposed to heat and ash and other chemicals. So how to identify such exposure on human health? What is the effective or how to check that?
First of all, we have got a compulsory health checkup every year for every employee or associate who is working with us, which gives a trend as to in what direction the things are moving. Secondly, if you see NTPC power stations, we have highest efficiency ESPs installed in our power plants, which ensure that the exposure to gas, this dust is minimal. In fact, if you go to the plants, you will see that the kind of housekeeping, the kind of the ash extraction arrangements, they are state of the art. And that's why uh, means there is no such risk. Maybe one or two cases might come, but then uh, rest of the people, they are every year screened for all the parameters and they are fit.
Yes, sir. Another question by Santosh asking, do we monitor microbiology parameters of the water used in power generation unit, as cooling tower water may lead to Legionella contamination, which is harmful and may lead to respiratory diseases?
I am not a chemical engineer. I will not be able to answer this question so such a depth. But then, what I can say is that there are defined parameters of water before it can be used in a power plant or before it can be declared fit for drinking. So those parameters are monitored, and then only it is allowed to be used either for drinking or for power plant operation. Because any deviation in chemical parameters of water will lead to long-term damage to the power plant. So we don't allow it.
I think I'll ask Colonel Sanjay Srivastavaji to ask his question, which is a long question. And Colonel Srivastavaji, and that's the last question, and then I'll hand it over to Dubeyji for winding up the session.
Good evening, sir. This is a.
Good evening, sir. Good evening.
I'm Colonel Sanjay Srivastava, sir, and I'm working with the Climate Resilient Observing System Promotion Council. We have launched a Lightning Resilient India campaign, sir, and we are mapping lightning surge in India. And in our research in last 1.5 years, we have found very sharp increase in lightning in the areas where power is being produced. And we are also working on the climate change adaptation methods. So firstly, our report is going to be of use to you, sir, which I'll be sharing with you. At the same time, the electrical losses which a power plant, incurs in due to these surges, they are yet to be assessed or measured. So we would request your help if we can be given access in measuring one or two sample cases, and we come out with a solution to it, that how to reduce it. So that will be good. And you also have plants in areas like Bihar, Jharkhand, Uttar Pradesh, Madhya Pradesh, which are the major lightning death areas. So there also some help can be given to the areas which are outside the plant and surrounding areas, where we can spread the awareness in saving life of the people. That's all from my side, sir. Over to you.
Thank you, sir. We'll get connected and we would discuss regarding this lightning, what is the label and all. We'll get connected.
Sure, sir. So, since we are talking about DRR, disaster risk reduction, there are a few critical questions which we cannot ignore. But then, when we have to take a trade off between development and disaster, I think we really need to look into renewable energy resources and try to minimize like coal energy or even hydroelectrical. I've been to Sikkim and I have seen that people are against big dams, and we have seen the river Tista, which flows into Gangtok, is almost dry. And on the river bank, you can see the chemical pharmaceutical industries there. So people there who are the local people want smaller dams, not the big dams. So I think these are the questions which are very important for us to address. At the same time, if we are too critical, we are called as anti-development. So how do we balance? Because definitely power energy is something which is required by each and every household. So I mean, I'm not putting you it in what you call katagara and then asking all the questions, though you have given such an excellent talk and raised such important issues. After this, I would like to request Dr. Dubey, but any comments on that, sir?
I think, madam, the aspirations of local people are very, very important. And it's very, very genuine to say that large size dams have got their own complexities and long-term problems also associated with that. So there are, I mean, every model of development has got its own brighter side and darker side. Now, that's why on development, we can't copy. Somewhere we failed when we started copying somewhere. Sometimes we tried to copy USSR, sometimes we tried to copy Japan. In fact, every geography has got its own positives and negatives as per development is concerned. And Sikkim, as you were saying, I think there is a merit in what people are saying. That much I can say, not more than that.
Thank you. Thank you so much, sir. It was wonderful listening to you. And we'll be very glad to invite you to university once things get normalized.
I just want to at least enter into the campus, that's all.
You can come and listen to see our campus and definitely share your thoughts and ideas with our students. We'll be very happy to have you in.
Thank you, madam. Definitely.
And I would
I'll get your number, and then once
sure,
I'm
I
ready,
have your number. I'll get in touch with you.
Okay.
I would like to now welcome Dr. Rakesh Dubey, who is the patron for industrial and chemical disaster risk reduction. He is a specialist and now a patron for this organization and the academy where he is now currently located. He served as director DMI, all of us know, and for those who have joined anew, he served as director for Disaster Management Institute located in Bhopal, which was started after Bhopal gas accident. With 30 years of experience in the area of environment and disaster management, working at regional, national levels, coordinating at various states, provided technical leadership in making on-site and off-site emergency management plans to various hazardous industries and state governments of India. He also provided leadership in completing risk assessment safety audits for various industries. Also working closely with NDMA and other ministries, I would like to welcome Dr. Rakesh Dubeji to give his concluding remarks and vote of thanks. Thank you so much. Sir, you have to unmute.
You are mute, sir, mute.
We can't hear you. You have to unmute.
Is it okay now?
Yes, yes.
Okay. Really, it's my pleasure that Sir Pandey, sir, like authority, spoke on this power sector. And sir, I would like to acknowledge Pandey, sir, especially because I know him personally since long. And I would like to share one principle of the disaster management. For any disaster management, there are 5 M. One is man, another is the material, third is machine, fourth is management, and fifth one is the money. And if any M is weak, you cannot add the disaster management. And Sir Pandey, sir, who is the ED of NTPC, he fits in the M of the man. He's an excellent person by personality to address any type of issues. And when we address the disaster management, he's having excellent personality addressing this M for the 5M. And he's very proactive on disaster management. He continues to support this. I know he has a vision and he's very sensitive on the disaster management also. And I would like to share, sir, no one knows it. You know, he is the instrumental and he is the person who was behind this whole concept which we created. Casually, I communicated one message through WhatsApp. Sir, this what I want to do. He said, no, go ahead. Only by that signal, I thought, let's go ahead. So, sir, really thank you for the nice presentation. And I wish that you should continue and you should extend your support for the disaster management and environment, what you have done in the past. We expect, society expect from you for the betterment of the disaster management. Now, it's very important for the technical aspect of this power sector. It is my observation to the all audiences, especially to the industries persons and also for the academics, especially for the GNU professors and others. If you see any type of the debate in reference to the Sendai framework, you see still there are some debates are going on, and yesterday a lot of debates happened. All were discussing on the natural disaster side. Why not on the technological side? So this our effort we try to do. First, I think this is the unique type of program we initiated for the all audiences through this program, and we try to address all those vital components of the society. If anything goes wrong, either side, society will be affected. If power is not there, ultimately society will have a negative impact. If anything goes wrong in the society, then power unit gets affected. So it needs proper balancing. To address that point, we thought to continue this type of program. And I hope the questions asked by various audiences definitely indicates that Pandey sir's lecture was excellent. And curiosity of the audience itself is a litmus test of a speaker. And the wonderful question itself is a testimony for this program. And also for all of us that sir has responded in a very professional way, and his experience reflected in his question, answer, and his presentation. Sir, we need such type of patronage from you for further such events or any of the issues which are required for the Sendai framework governance, this governance issue. I would like to thank Professor Sunita Reddy. She has coordinated very excellently, very fantastic way.
Just to add one point, I'm sorry to interrupt you. I just wanted to add that you said all 4 M's. So now that
five M's.
5 M's.
Man, it's a man. It's man means not only human being. It includes manpower, you can say it.
Yeah, so we maybe say human because all disasters are anthropocentric and we have to go beyond man-made disasters. In fact, as I said, anthropocentric. So we to have a general gender-neutral term. So that's the point which I want.
Okay, thank you, ma'am. Thank you for correcting the things. Thank you. And nicely you coordinated the program. Nicely you moderated. And I also learned a lot by way you moderated. And I understand you have included all questions except my question. I don't know why you have excluded my question.
Please go ahead.
Really, thank you, madam. And I hope, and we hope on behalf of organizers that you will continue for such type of support in near future in our program. Not only such program, but some other studies also this academy is planning to do. This is the first one. I would also like to acknowledge and thanks Colonel Sanjay Srivastava and his distinct council, CROPC, that he also supported and he had guided us in organizing this program. My friends, Mr. Ram and Narendra, now everyone knows him, Mr. Ram and Narendra, very fantastic name there, how they are quickly coordinating and fixing the issues. I have seen their performance in the morning. There was some issue of the fixing some registration, but they fixed it. So thanks our partner, Mr. Narendra and Ram from HealthCrum for fixing the thing. And I hope that this is just the beginning. We have to go long ahead in this sector because this is not professionally much addressed in the country. It is addressed very casually. So with all these words, I thank all of you, and officially I close the this meeting. And lastly, sir, thanks for Pandey sir, Madam Sunita ji, to all. Sir, we need your blessings for future also. Thank you, sir.
Thank you, sir. Thank you so much.